Let's consider these questions on velocity time graph. The diagram on the board represents a velocity time graph of a body. Determine the distance covered by the body. Okay? We are asked to find the total distance traveled by this body. Don't forget, in our previous class, I told you that when we talk about the distance covered by a body on a velocity time graph, we are talking about the area of the shape. You understand? Area that the area given by the shape of the velocity time graph is known as the distance covered by the body. You understand? Now look at this velocity time graph. What is the name of this shape? Well, you might be wondering that how will I determine the name of this shape? Just take it one by one. Take each segment by segment. You can see that shape A look like this. Let's start. Solution. We are asked to find the total distance. Total distance. Now, this is how shape A look like. We have something like this. You know, and we have from this point to this point is 3. Then you know that, please pay attention. Shape A. Let us draw shape B. This is how B look like. We have B, and this is how C look like. You can see that I've already divided the shape into segments. This is C. Now, pay attention. C. What is the name of this shape? Okay, forget about the, don't let us put the numbers now. What is the name of shape A? Shape A is a trapezium, you understand? Because if you want to draw a trapezium, you can draw a trapezium like this. There are 2 ways to draw a trapezium, and you can draw a trapezium like this. You understand? Oh, sorry. You understand what I'm trying to say? See, shape A is a trapezium, but this is the kind of trapezium that shape A look like. So you know that areas of a trapezium is given by this formula. Area is equals to 1/2 multiplied by A plus B times H. You understand? And shape B looks like a rectangle, okay? Because if you want to draw, you can, this is how shape B look like. The opposite side of all the rectangle are equal. This side is equal to this, and this side is equal to this. And it has 2 equal sides. I mean, it has 2 equal sides. You understand what I'm trying to say? That is, this side and this side are equal, and this side and this side are equal. So in that case, you know that the area of the rectangle is what? Length times breadth. Okay? Now, for the last shape, which is C, this is how the shape look like. What is the name of this shape? This is a triangle, and the area of a triangle is equal to 1/2 multiplied by base multiplied by height. You understand? So now, having identified the shapes and the corresponding value formula for finding the area, you can proceed to calculate the total distance traveled by the object. You understand? Okay, let's take it step by step. Let's start with the trapezium. Okay, for the sake of clarity, let me redraw the trapezium as we have in the diagram. This is how we have it in the diagram. We have it like this. Like this. Okay. Now, please pay attention. From this point to this point is what? 3. Okay. So I'm going to have 3. So here, the distance here is 3. Oh God. I don't want to. Please just pay attention, okay? Let me take another marker. From this point, see, from this point to this point is 3. So I'm going to have 3 here. Now, from this point to this point, listen, from this point to this point is 10. You understand? The distance from this point to this point is 10. Okay, so I'm going to have here will be 10. And the distance from this point to the extreme end is what? Is 20, because this is let me go the 20 here. You can, if you trace it, you're going to discover that the distance from this point to this point is 20. That is, this distance is 20. So I'm going to have here will be 20, and so we've already filled what we need to calculate the area of the trapezium. Now let's proceed to the rectangle. Now the rectangle is what? Okay, let us name it. Let us call this A. Let's call this A. Let's call this B. Let's call this C, D, E, F, You understand? The rectangle aspect is CDGF. You understand? CDGF. And you know that the distance from this point to this point will be the difference between 10 and 3. Okay? Listen. I need the distance from this point to this point. Okay? The distance from this point to this point will be the difference between 10 and 3. 10 minus 3 will give me what? 7. So the distance from this point to this one is 7. So let us have 7 here. 7. Now, if this side is 7, that means that this side will also be what? Will be 7. Okay? Please kindly pay attention. Now, we know that the distance from this point to this point is what? Is 20. So I'm going to have 20 here as well. And 20 will be also here. So in that case, I'm going to have 20 here, 20, and 7 here, and 7. Okay? You can see that the sides are equal. That's why I know that it is a rectangle. Okay? Rectangle has the two opposite sides equal. Okay? Now, let us proceed to the triangular aspect. Now, with respect to the triangle, I need the distance from this point to this point. The distance from this point to this point will be the difference between 10 and 15. Okay? So 15 minus 10 will give me 5. So here I'm going to have 5. Okay? Then, now, don't forget that the distance from this point to this point is what? Is 20. So I'm going to have 20 here. So I've already filled out the sides that I need to calculate the area of the respective figure that we have. Now, let us start with the trapezium. You might be wondering that what is the A and B in this formula. A and B are the two parallel sides of the trapezium. You understand? Don't forget, parallel sides, they are sides, or parallel lines are lines that they can never meet. You understand? They travel on a straight line. And if you look at a trapezium, trapezium has two parallel sides, which is this and this. Okay? So let's proceed. The area will be, for the trapezium, I'm going to have 1 over 2 multiplied by A. A is the longest side, which is 20. B is the shortest, which is 10. Multiplied by H. H is the distance between the two parallel sides. You understand? See, if you can redraw the trapezium like this, okay? This is 10, this is 20, and this is 3. You understand? You can see that the distance between these two parallel sides is what? Is 3, which is the height, okay? So here I'm going to have multiplied by 3. And for this, we're going to have length times breadth. If you withdraw the the rectangle, you're going to have something like this. This will be 7, and this will be 20. So the length is 20, and the breadth is 7. Okay. And for the right angle, for the triangle that we have here is 1 over 2 base times height. So I'm going to have 1 over 2 multiplied by base. The base is 5, and the height is here. This is the height, which is 20 multiplied by 20. Okay. So let us calculate. 20 plus 10, that is 30. 30 times 3 is 90. You understand? 20 plus 10 is 30. 30 times 3 is 90. Okay? 90 divided by 2 is 45. So I'm going to have 45 meter here. Then 20 times 7. 20 times 7 is 140. Okay? So I'm going to have 140 meter here. Now for this, 5 times 20 is 100. 5 times 20, 100. 100 divided by 2, that is 50. So I'm going to have 50 meter. Okay? So the total distance is the summation of all the individual figure. The summation of the area of individual figure that we have in our velocity time graph. So the total distance is equals to 45 meter plus 140 meter plus 50 meter. Okay, 45 meter plus 140 meter plus 50 meter, that is 235. So yeah, the total distance will be 235 meter. Okay, that is the final answer to the question. Okay, if you have any question, let me know in the comment section. See you in the next class.